In the last episode, we saw how AI learns from training data. But once the training is finished, another mystery begins. You type a sentence, and the machine answers as if it understands you. It explains, compares, translates, jokes, and summarizes. So what is it actually holding inside? A thought? A definition? A memory? Or something stranger? A map made of numbers. A language model does not read words the way you do. It has no eyes moving across a page, no inner voice sounding out a sentence, and no childhood memory attached to the word rain. Before the model can do anything, language must be translated into a form the machine can process. The first doorway is called tokenization. A token is a small piece of text. Sometimes it is a whole word, sometimes it is part of a word, sometimes it is punctuation, a space, or a cluster of characters. The sentence does not enter the model as one smooth ribbon of meaning. It is cut into glowing shards, small enough for the machine to count, compare, and pass forward. After the sentence is split, each token is matched to an ID in the model's vocabulary. The word or word piece becomes a number. This number is not meaning by itself. It is more like a library index card. It tells the machine which symbol has arrived, but not yet what that symbol is related to, what it usually means, or where it belongs in the wider pattern of language. That is where embeddings enter. An embedding turns a token, sentence, or document into a vector, a list of numbers. You can imagine each list as coordinates on a vast map. Not a map of countries and oceans, but a map of relationships. The model is no longer only asking, which token is this? It is asking, where does this piece of language sit among all the others? On this map, distance matters. Words, phrases, or documents that are used in similar ways can end up closer together. Cat may live nearer to kitten than to volcano. Doctor may live nearer to hospital than to violin. The model does not see fur, lava, medicine, or music. It sees patterns of use. Meaning becomes a kind of geography. But this geography is not flat. A real embedding does not have just left and right, up and down. It may have hundreds or thousands of dimensions. We cannot draw that space honestly on a screen, so we reduce it into images, stars, cities, constellations, roads. Inside the model, each direction may carry a subtle, statistical relationship that no human label can fully name. This is why AI can make surprising connections. If two ideas live near each other in the vector space, the model can treat them as related even when they do not share the exact same words. It can connect physician with doctor, or tiny home with small house. Search becomes more than matching letters. It becomes searching neighborhoods of meaning. Still, words do not have only one meaning. A bank can hold money, or a bank can slope beside a river. A model must use context to decide which neighborhood matters. The surrounding tokens pull on the representation like gravity. In one sentence, bank drifts toward finance. In another, it drifts toward water, mud, and the edge of a stream. This is where the transformer's attention mechanism becomes useful. Attention helps the model weigh which earlier tokens matter most for the next step. It is not human attention with desire or awareness. It is more like a lantern moving through the sentence, brightening relationships that help the model predict what should come next. When tokenization, embeddings, context, and attention work together, the result can feel astonishing. The model can answer a question it has never seen in exactly that form. It can translate style, summarize arguments, and compare ideas across fields. It feels like understanding because the mathematical map captures many real regularities in the way humans use language. But a map is not the territory. The model can place words near other words without ever touching what those words point to. It can know that fire is near heat, smoke, danger, and cooking, without feeling warmth on skin or fearing a burning room. Its meaning is relational. Human meaning is also lived, sensory, emotional, social, and embodied. Humans connect words to bodies, memories, goals, needs, and consequences. The word home may mean architecture, family, safety, conflict, rent, longing, or loss. A model can learn patterns around all of those meanings, sometimes with great subtlety. But it does not need shelter. It does not miss a place. It does not stand inside the word. So the right question is not simply, does AI understand? The better question is, what kind of representation is it using, and where does that representation break? AI has mathematical maps of language that can be useful, flexible, and sometimes beautiful. But usefulness is not consciousness. Fluency is not experience. Similarity is not wisdom. Episode 04 gives us the next piece of the atlas. Training builds the patterns. Tokens open the gate. Embeddings place language into space. Attention traces the routes. But the human world still remains larger than the map. AI can navigate symbols with remarkable skill. Humans live among the things those symbols are trying to name. That difference matters.